Now I want to make a tangent on this point of contact. So y into t, you will get x plus at square. So what would be the process? Process is simple. Hello everyone, welcome back to LN Overseas. Let's continue a special series. In this series, we will cover 45 important topics in 45 days, which will really helpful to all JEE Mains aspirant. And the topic distributions are 15 physics, 15 chemistry and 15 maths. I am going to cover this math section here. This is the study challenge we will cover in this series. So without wasting too much time, let's start our topic. And our topic is tangents, which is under the chapter Parabola. We are going to discuss the tangent special topic in this chapter Parabola. You can see a lot of previous year question on the basis of this topic only. So the first one form, there are the Cartesian form. It is also known as the point form. See, we have the equation of a tangent in three form: point form or a Cartesian form. Second one is a parametric form. Third one is slope form. I will tell you in which case we will use particular equation. So first of all, we have to understand what is point form or a Cartesian form. So let's visualize first of all. Let's say I have a parabola that is y square is equal to 4ax, and I am going to take y square is equal to 4ax for all the cases, right? As I told you, you can just apply the same concept for the remaining one. Now, y square is equal to 4ax, we have a one parabola at any particular point. Let's say this point, I want to make a one tangent. So the tangent like in this way, So you have this point of contact, which is P, which is something like x1 comma y1. Now I want to make a tangent on this point of contact for this parabola. So how we can make? First of all, for any equation of a line, if you want to design, so what is the must be requirement? The must be requirement is the slope as well as a one point. You have a point, no problem, but you don't have a slope. So we need to do the work for the slope, and we can do it very easily because we have a one concept, that is y square is equal to 4ax we have. So we can simply do the differentiation of this one. Then I will get 2y dy by dx is equal to 4a. After getting the cancellation, you will get dy by dx, which is equal to 2a upon y. Now this y, that means you need to put at this point, we are going to find the slope. So that means we need to put x1 comma y1. Unfortunately, there are no x1, so we need to put only y1, y coordinate. So you will get 2a upon y1 is the value of slope, right? This is your slope. The derivative, first derivative, it is also known as the slope, the basic thing. Now, you have a slope, you have a point. So what are you waiting for to design the equation of this tangent? You can use your point slope form, then you will get y minus y1 is equal to m, that is 2a upon y1 x minus x1. Now do the cross multiplication, you will get y into y1 minus y1 square is equal to 2ax minus 2ax1. After this, you will get what? Y into y1 is equal to 2ax minus 2ax1 plus y1 square. But y1, that means y1 is also the point of this parabola, so it will be satisfy this curve also. You can put here y1, so y1 square you can also replace with 4ax1, right? So I am going to write here 4ax1 in place of y1. Now y1 you will get 2ax minus 2ax1 plus 4ax1. So 4ax1 minus 2ax1 you will get 2ax1. So 2x plus 2ax1. You can take 2a common, then you will get x plus x1 is the equation of parabola, is the equation of tangent for this parabola. But I can consider your feeling. This is quite lengthy approach, and we have to do for all the cases. Remaining 3 parabola also we have. So yes, I can consider your feeling, and I have one shortcut, and the short trick which is totally based on the transformation. For this shortcut, you just need to remember some basic transformation, which I am going to tell you. That is like x square, we need to replace with x into x1. Y square, we need to replace with y into y1. Similarly, x you need to replace with x plus x1 upon 2, and y you need to replace with y plus y1 upon 2. The basic transformation you can remember. Apart from this, xy also you can replace with xy1 plus yx1 upon 2, but although there are the no uses. So initially, you just need to remember these four. If you know these four, then trust me, you can easily write the equation of any parabola. For example, I want to write the equation of tangent for this parabola. So the equation of tangent for this parabola, you can easily write, that is y square you can replace with y into y1 is equal to 4a. X you can replace with x plus x1 upon 2. Then you will get what? Twice. So y into y1 is equal to 2a x plus x1. That's it. Basic, easy, short. And this approach you can just copy paste for other parabola also. You will get the equation of a tangent in point form or in Cartesian form. This form, it is also known as point form. I hope everyone understood this one. Now continue with the second part, and the second type that we have is parametric form. You know, the parameter we usually take to simplify our calculation. And in case of the parabola, again I am going to consider first type of the parabola. So for that one, I am going to consider again, now at this point of contact, I am going to make a one tangent. Then you can make like in this way. This is your point of contact P. Now I am going to take in place of x1 y1 at square comma 2at as a point of contact for this parabola. Still you have same parabola y square is equal to 4x I am going to consider here. Now the only change is at square 2at now we have, but still we need to stand our work. That is what? Simple. I will use my transformation which I did in my previous one. Here I did there t is equal to 0. This one now I will say like it is t is equal to 0. T is equal to 0 is what? Equation of a tangent, right? And t is basically stand for the transformation. Now again I would like to do the same kind of the work here, but now here we have at square comma 2at, not a issue. Y square is equal to 4ax, we have y into y1, but y1 we have 2at, so I am going to put here 4a. X I can replace with x plus x1. x1 we have at square upon 2. X plus x1 upon 2. Quite easy. Now you can solve this thing. Then you will get 2at into y, which is equal to 2a x plus at square. You know, after getting the cancellation, you will get, again also you can cancel this a. So y into t, you will get x plus at square, which is your equation in parametric form. Quite easy to understand because we have a shortcut. And yes, similarly we can perform the different thing in slope form. Now the third one, we have slope form. For the slope form, what we need to do? First of all, we need to understand the proper scenario. Now here we have y square is equal to 4x and y is equal to mx plus c. So let's say again I have a one parabola, that is y square is equal to 4x, and I want to make a one tangent, but now this time I don't have any point of contact. You can say now in that case you have one external point, that is like alpha comma beta. From this one we need to make a one tangent. So in short, you can also understand in exam if you are confusing like sir in exam which form we need to apply. So always remember, if you have a point of contact, then you can apply your first point form or a parametric. But if you don't have a point of contact, you have any external point, so in that case you need to come for slope form, right? So here y is equal to mx plus c we have, y square is equal to 4x we have. What we need to do? First of all, we need to solve these two. Obviously, this point of contact, if you want to find, so this is the intersecting point of this common point of this line as well as of this parabola. So in short, we need to solve these two. And at this point of contact, when we are going to solve these two, we will get a quadratic equation in terms of x. And my concept is simple. At this point, my discriminant must be equal to 0, isn't it? So here I am going to apply this concept here. Y is equal to mx plus c, I am going to put here first of all. So here you will get mx plus c whole square, which is equal to 4ax. Now here you can do the simple square, then you will get m square x square plus c square plus 2 mx into c is equal to 4ax. Now you can simply write everything in the LHS, then you will get something which looks like perfect. X you can take common, you have 2mc minus 4a plus c square is equal to 0. You have one equation. And this equation you can treat it like quadratic, which is in terms of x variable, ax square plus bx plus c. Now for this equation, what would be the must be condition? The must be condition for this, your discriminant must be equal to 0, because it is here. The roots must be equal, right? So if the roots are equal, discriminant must be equal to 0. So b square, now 2mc minus 4a whole square minus 4ac, that means minus 4 m square c square, it should be equal to 0. Now you can solve this equation. This is quite easy. A square b square minus 2ab 16amc minus 4m square c square is equal to 0. So 4m square c square would be cancelled. Here only you have 16a, you can take common. So you will get what? 16a, then a minus m into c. So this a will never ever will become 0 because it not exist here. Then a is equal to mc, that means you can say c would be equal to a upon m, and this will be known as the condition of tangency for the parabola. This is very important one, right? Apart from this, condition of tangency in parabola, condition of tangency in circle, condition of tangency in ellipse also, everything is important one, right? There are the question in your previous year. That's why I am telling you this thing. So now come to the point. C is equal to a upon m is happen. That means you are eligible to make a one tangent on this parabola. Simple thing, right? Now c is equal to a upon m, you can simply put here, replace this c with a upon m. Then you will get y is equal to mx plus a upon m is the equation of tangent in slope form for y square is equal to 4ax. This is for y square is equal to 4ax. Similarly, you can do same concept, just apply for the remaining 3 parabola. You will get 3 different equations, which is quite easy, right? And now it's time to apply these concept in your one previous year question. So the one previous year question we have, that is, if y is equal to mx plus 4 is a tangent to both the parabola, y square is equal to 4x and x square is equal to 2vy, then we need to find the value of b. This is from 2020 JEE Mains. So what would be the process? Process is simple. I have 2 parabola, y square is equal to 4x and x square is equal to 2vy. So let's say y square is equal to 4x we have like in this way, and x square is equal to 2vy we have like in this way, right? X square is equal to 2vy, y square is equal to 4x. That's it. And now this line y is equal to mx plus 4 is a common tangent for both the parabola. Trust me, common tangent concept is very, very important. Do as much question as you can from circle, parabola, ellipse. Combination of circle, parabola, ellipse, even the circle and parabola, you can see a lot of previous year question either in your JEE Mains and advance, right? So here come to the point, y is equal to mx plus 4 is a tangent for both the parabola. So that means first of all I would like to pick y is equal to mx plus 4, and actually the equation of tangent for y square is equal to 4x we can make simple. The concept we already have learned, we don't have any point of contact, so I hope everyone understood what I am going to apply. I am going to apply my slope form here. So the slope form says us y is equal to mx plus a upon m is there. Now you know y is equal to mx plus the value of a from this parabola you can pick, which is equal to 1. Now this equation directly you can do the comparison with y is equal to mx plus 4, right, because it is same. So the constant term we are getting on comparison, we are getting 1 upon m, which is equal to 4, you know. So m you will get 1 upon 4. Now you can design the exact equation of tangent, that is y is equal to mx plus 4. Now m you can replace with 1 upon 4. So y is equal to, now we have x upon 4 plus 4 is there. Now because this is the common tangent, that means it must be satisfied here also. So you can put now this value in your this parabola, x square is equal to 2by. So I am going to put this, put in x square is equal to 2by. Now we will get what? Quite easy. X square is equal to 2by. You can replace with x upon 4 plus 4. So you will get x square. Now you can write everything in the LHS, then you will get minus 2, you will get cancel, bx upon 2 and minus 8b is equal to 0. Now you have a quadratic which is something like is this type. Now again the same concept, if our tangent which is like in this way, right, common for both. So you know here at this point the value of discriminant must be is equal to 0. The roots must be equal for individual this parabola. Yes, it is, right. So again the discriminant must be is equal to 0. You know b square, that means b square upon 4 minus 4ac minus minus plus 4ac, that is 32b, it should be is equal to 0. So b you can pick common, then you will get b upon 4 and here you have 32 which is equal to 0. So b, it is not possible you can take 0, right, because parabola will not exist. Now here you can take LCM, then you will get, now it is quite easy to solve, b plus 128 is equal to 0. So you will get b which be equal to minus 128, and that would be the final answer. You can see in option number C it is. That's all from my side on this topic. Don't forget to watch the complete series. The playlist link is available in description box. Still, if you have any query or any suggestion, feel free to reach out to us through the comment section. For more updates, stay tuned with us. Thank you.